Good morning, Abby. This is lesson 110 through 111. So in this lesson, we are learning how to graph on the number line these inequality values. So if a number, these two factors create a number when we multiply them together, they create a value. If that value is greater than 0, then this has to be a positive number. You see my logic? So let me write that down for you. That's one of the things that we need to know. If it is greater than, it must be greater than 0, must be a positive number. Okay, so that is the premise that we're working from. Greater than 0 must be a positive number. So that means if we have this value here, A times B greater than 0, then A times B must be a positive number. So in order to get a positive number when we have two factors, we must have a positive times a positive, or we must have a negative times a negative, because both of those would be positive numbers, right? A positive times a positive is a positive, and a negative times a negative is a positive. So we work from the premise that either we have a, positive B, or we have a, negative B. That's what we're working for. So we're going to apply this concept of it being positive to the symbol here. So we would set A greater than 0 for it to be positive, and we would set B greater than 0 to be positive. So we can solve for whatever A is and whatever B is. And the same thing here. If greater than 0 must be a positive number, then less than 0 must be negative, right? So if less than 0 must be negative, in order for A to be negative, A has to be less than 0. In order for B to be negative, B has to be less than 0, right? We're not really worried so much about the sign here. This part tells us what these values should be in order for them to be greater than 0 when put into the original equation. And then we're going to solve for A and B on both sides. And then we're going to see which one is true, right? We'll substitute a number that fits this back into the original equation to see if it remains true. All right, so I'm fixing to start on this first problem. So I'm going to roll this up. So if you need to take notes, then we're going to pause me, but I'm going to roll it up. All right, so we're going to graph on the number line. We have x plus 1 times x minus 2 is greater than 0. So if we work from the premise that we have a positive, so positive, then x plus 1 must be greater than 0, and x minus 2 must be greater than 0. If we work from the premise that it could be negative times a negative, then x, I don't know why I'm doing a parenthesis here. Parenthesis should probably be here. Positive times a positive, and otherwise it looks like divided by, right? Negative times a negative. So if we work from the negative, then x plus 1 should be less than 0 if it's negative, and x minus 2 should be less than 0 if it's negative. Now we're going to solve. So we subtract 1 from both sides. X is greater than negative 1. We add 2 to both sides. X is greater than a positive 2. We do the same thing over here. We would say x is less than a negative 1, and x is less than a positive 2. So now we have solved for x for both situations. Now we're going to see which ones actually make our equation true. And typically that's going to be one from either side. And I'll show you how that works. So we're going to take the original equation, And we're going to find a value that is true for this. So what's a value that is greater than -1? 0. 0 is 1 greater than -1. So 0 plus 1, I'm substituting 0 in for x, times 0 times -2 must be greater than 0, right? So that would be 1 times -2 would be -2. Is that greater than 0? No. So it is not going to be that term. So now we have to try this one. X is greater than a +2. What's the next number greater than a +2? +3. So 3, we're substituting it in for x, plus 1 times 3 minus 2 greater than 0. When we do this part, we're always going back to this equation. It's not about this anymore. It's about this. We're testing it by substituting in a value. All right, so we have 4 times 1, +4, that's greater than 0. So this one is true. Now, typically when we do these, if this one's not true, this one is true. This one is true, then this one's not true. That's usually the way it works. Not always, so you have to test them all. So x is less than -1. A number less than -1 is -2. So we're going to substitute -2 for x. So -2 plus 1 times -2 minus 2 is greater than 0. So that's going to be -1 times -4. Negative times negative is a positive. So +4 is greater than 0. So this one is true. All right, and so we're going to do the same thing here just to make sure. I'm going to substitute in a number less than 2 would be just a +1. So 1 plus 1 and 1 minus 2 greater than 0. So 1, or that's 2, I should say, 2 times -1 would make a -2, and that is not greater than 0. So these are the ones that are true. So these are the ones that we graph. So we want to look at that and evaluate, see how we can write that. So I'm going to change to red just so it stands out. So if x is greater than 2, right? X is greater than 2, but x is less than -1. So we have an or statement here. Or it's both of them. Those are the conditions where x is going to be a true statement when you substitute it into this equation. So I'm going to graph this. I'm just going to pick a color. Let's do blue. I just gave y'all a bunch of different colors. There's no necessary color to choose. So x is greater than 2. We would just circle the 2 and go this way. X is less than -1. We would circle the 1 and go this way. And that's how you would graph that. So you're just working from the premise of whatever this sign is, whatever this inequality symbol is. If it's greater than, it has to be a positive times a positive or a negative times a negative. And then we test it. And once you test it, then whatever proves true, those are the values that you graph. Not hard, just a little bit like tedious. There's a lot of steps. That's all it is. All right, we'll do another one. All right, so let's look at this one. We've got x squared minus 3x greater than or equal to 4, and our domain is integers, which is just basically, we don't even have to write that down. That's just telling us how to graph it, right? So what we need to do is set this equal to 0. X squared minus 3x minus 4 greater than or equal to 0. So in order to get this to where we can find some factors, we have to factor it, right? Makes sense. So if I factor this out, -4 that equals a -3, that's going to be x minus 4, x plus 1. All right, so now that it's factored, we can do the same thing we did before. If we have positive times a positive, I'm going to put this in a little box. Then we would have x minus 4 is greater than 0. Notice that this is greater than or equal to, and I've put greater than here because we don't care about this symbol right now. We care about this symbol, right? We care about it being a positive number. And if it were greater than or equal to, it might not necessarily be positive because 0 is neither positive or negative. So we're looking for positive numbers. All positive numbers are greater than 0. So we don't care about this symbol until we go to substitute in the value. Okay? And then that means x plus 1 would be greater than 0 also. But if we're doing negative times a negative, then that's going to be x minus 4 is less than 0, and x plus 1 is less than 0. So x is greater than a positive 4, x is greater than a negative 1. X is less than a positive 4, x is less than a negative 1. Now we test for solutions. So I'm going to go right back to this last one right here, and I'm going to substitute in a value greater than 4. So I'm going to go with 5 for x. So 5 minus 4, 5 plus 1. Is that greater than or equal to 0? Now I go back to that same inequality because now I am actually testing the inequality, the whole statement, right? So I've got a positive 1 times 6 is 1 times 6 is 6. It is greater than 0. So this is a true statement. So let's try this one. I'm going to say greater than negative 1 is 0. 0 minus 4, 0 plus 1. Is it greater than or equal to 0? Negative 4 times 1 is a negative number, so it is not true, right? So chances are this one is going to not be true, and this one is going to be true. We're just going to test it to make sure. So I've got x is less than 4, so that'd be a 3. Minus 4. 3 plus 1. Greater than or equal to 0. That would be negative 1 times 4. Not true. So if x is less than negative 1, that would be a negative 2. Greater than or equal to 0. Negative 6 minus 1. Negative 6 times negative 1 is a positive 6. So that is a positive number is greater than or equal to 0. So those are my true statements. So those are the ones that I'm going to graph. This one and this one, right? You're starting to get the hang of that. It's all about testing them out to see which ones fit. So I've got x, what I'm going to graph is x is greater than 4 and x is less than negative 1. So this is an OR, this is a disjunction. So greater than 4 integers is going to be, I really can't graph anything over here, can I? So I can do this, I can do a little arrow over here, and I can do less than a negative 1. So that would be undo. It would be this, 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 I'm pretty sure. So yeah, I think that's all we can do is take that off right there. I think that's all I can do. Let me double check that one. Okay, so what I did not do, you're supposed to take this symbol, right, with the equal sign. You're supposed to, if it has an equal sign, you're supposed to apply it. So that means I should have said greater than or equal to, less than or equal to. So that means when I graph it, I'm going to graph the negative 4, negative 3, negative 2, and the negative 1, and I'm going to graph the positive 4. that would be the correct answer because of the inequality sign there. All right, so that's what I have to do. All right, so next problem. Graph on a number line. So we're going to do, here's the problem. Come on. We've got x plus 2, x minus 4. It's the same thing. It's just more of the same thing. Greater than 0, and it's reals, so we'll use lines instead of dots. So if it's positive, positive, then we're going to have x plus 2 is greater than 0 would be, be x plus 2 greater than 0, x minus 4 greater than 0. Negative, negative, x plus 2 less than 0, x minus 4 less than 0. So x would be greater than negative 2, x would be greater than a positive 4. X would be less than a negative 2, or x is going to be less than a positive 4. So we just test, figure out which one is true. Greater than negative 2 would be a negative 1. So negative 1 plus 2, negative 1 minus 4, greater than 0. All right, so negative 1 plus 2 is 1 times negative 5. That is not greater than 0. So it's not that one, which means it has to be this one. Okay, so I'm going to test this one. X is greater than 4. Let's do 5. So 5 plus 2, 5 minus 4. That's 7 times 1. It is greater. So it is this one. It is not that one. Right? Which makes sense if you think about it. If x is greater than 4, it can't be less than 4. That's the opposite. So our solutions here are x is greater than 4, x is less than negative 2. That's an OR statement. So we would graph it that way. It's reals. So we would find negative 2, and we would go to the left because it's less than. We would find the positive 4 and go to the right because it is greater than. All right. You see how easy these are. These are not difficult. You can wrap your head around them. That'd be great. So all I need to do here is go ahead and I'm going to subtract 5 from both sides. And then I'm going to factor. That would be x minus 5, x plus 1 greater than or equal to 0. So positive times positive would be x minus 5 greater than 0, x plus 1 greater than 0. Negative, negative, x minus 5 less than 0, x plus 1 less than 0. X is greater than 5, x is greater than negative 1, x is less than 5, x is less than negative 1. Let's test the 5s, see if it's greater than or less than. So x greater than 5, 6 is greater than 5. So we'll use 6 minus 5, 6 plus 1, greater than or equal to 0. That's 1 times 7. It is greater than 0. So this one is true. This one is false. Okay. Let's do this one. Greater than negative 1. 0 is greater than negative 1. So 0 minus 5. 0 plus 1. Negative 5 times positive 1. Is that greater than 0? No, it is not. It's not this one. It is this one. So we are going to be graphing x is greater than 5, x is less than negative 1. And that's an OR statement because they go in opposite directions. and it's integers. And there is an equal sign, so we put an equal sign on here. So greater than or equal to 5 in the domain is integers, so I'm going to put a dot on 5. Less than or equal to -1, so -1 and then going this way. Easy peasy, right? You just have to wrap your head around what is the inequality saying? What does it really mean? When it's greater than, it has to be positive. And those are the two ways we get a positive. That's the end of lesson 110. Now we're in lesson 111. Let me look in my book and see what that is, because they all run together. It is the 3 statements of equality. So basically, you're going to be getting 3 things in your word problems instead of 2 things to compare. Nickels, dimes, and quarters problems. But now we're, instead of just nickels and dimes or dimes and quarters, it's nickels, dimes, and quarters. So that means you're going to have 3 equations, not just 2. You're going to have, before we used to just have a quantity and then a value statement. Now we're also going to have a comparison statement to go with that. That gives us a value of one compared to the other. So a quantity, a value, and a comparison. So let's look at this first problem. There were 35 nickels, dimes, and quarters in all. That's our quantity statement. So nickels plus dimes plus quarters is equal to 35. Value statement. Their value was $5. So 5 times nickels plus 10 times dimes plus 25 times quarters, that's their value, is equal to $5. When we don't write with decimals, we go all the way out, right? We count pennies. And here's our comparison statement. How many coins of each type were there, if there were? 2 times as many quarters as nickels. So quarters is going to be equal to twice the number of nickels. So this is our comparison. Quarters is equal to 2 times nickels. All right, that also gives us a substitution value. So we can put that into both of these statements right here to get a new value. So I'm going to substitute that into the first statement. N plus D plus Q is 2N is equal to 35. So that means that 3N plus D is equal to 35, right? And I can do that here as well. And I get 5N plus 10D plus 25, and the value of Q is 2N. That equals 500. So 5N plus 10D plus 50N is equal to 500. So 55N plus 10D is equal to 500. All right, so now I have a situation where I can actually use this to create a substitution value for D if I want to solve it that way, and I think I will. So D is equal to 35 minus 3N. So I'm going to put that in for D. 55 times N plus 10 times D, and D is 35 minus 3N is equal to 500. So 55N plus 350 minus 30N is equal to 500. If I subtract 350 from both sides, that would cancel. And I'm going to say 55N minus 30N. That gives me 25N is equal to 500 minus 350 is 150. So n is equal to 6 because there are 6 quarters in $1.50. So now that I know that there are 6 n's, I can come back in and I can substitute here, actually. D is equal to 35 minus 3 times 6. So D is equal to 35 minus 18. D is equal to, I'm going to use my calculator because my brain is not working, 17. Okay. I can also come up here and I can use 6. 2 times 6 equals 12. So Q is equal to 12. So I have 6 nickels, 17 dimes, and 12 quarters. And those are correct. So that's what you're looking for in each of these problems. A quantity, a value, and now we're adding a comparison statement, which creates a substitution value to help us solve. So let's do this one. We've got 28, so our quantity statement is 28 nickels, dimes, and quarters. So nickels plus dimes plus quarters is, there's 28 of them. Now our value statement, 5 times n plus 10 times d plus 25 times q is equal to $2.50. How many coins of each type were there? If there were 5 times as many nickels as quarters. So nickels is going to equal 5 times quarters. Okay, so there were 5 times as many nickels as there were quarters. So we take the quarters, multiply it by 5, and that's how many nickels we have. So again, quantity, value, comparison statement. And your comparison is going to give you a substitution value that you can use. So 5q goes into n, so 5q plus d plus q equals 28. So 6q plus d is equal to 28. I can create a substitution value from that and say that d is equal to 28 minus 6q. So now I could actually take this one and drop it into this one and solve for q right away. So 5n, that's going to be 5q, plus 10d, that's going to be 28 minus 6q, plus 25q is equal to 250. So 25q plus 280 minus 60q plus 25q equals 250. So if I subtract 280 from both sides, this gives me a negative 30. And 25 plus 25 is 50. 50 minus 60, that's a negative 10q. So negative 30 divided by negative 10, q is equal to 3. There's 3 q's. So now I can solve. N is equal to 5 times 3, that's 15. And D is equal to 28 minus 6 times Q. So D is equal to 28 minus 18. That's going to be 10. So I have 15 nickels, 10 dimes, 3 quarters. See how easy that was? We really didn't even use a lot of space. So I do recommend going ahead and getting substitution values for n and a substitution value for for 2 of them and putting them into the one big problem first. So you don't have as many steps, right? You can do it all at once. Next problem. Okay. The total number of blues, greens, and yellows in the pot was 10. So we have the number of blues, greens, and yellows was 10. The blues weighed 1 pound and the greens weighed 4 pounds. So we have 1 times the blues plus 4 times the greens plus the yellows weighed 5 pounds. 5 times the yellows equals 39 pounds. So that's our value statement. Quantity, value, now we need a comparison. If there were 2 more yellows than greens, how many of each color were there? So yellow is equal to greens plus 2. So we have a comparison statement here. We have yellow is equal to greens plus 2. So we're going to substitute that in up here to get a value for G. Or B, one of the two. Yeah, we're going to get a value for B. So we've got B plus G plus Y is G plus 2. G plus 2 equals 10. So we've got subtract 2 from both sides. So we've got B plus 2G is equal to 10. So I'm going to subtract 2G. B is equal to 10 minus 2G. Now I have a substitution for Y and I have a substitution for B. We're going to put that into the main problem. So 1 times B. B is 10 minus 2G. So we just put that straight in for that. We don't know what G is. We don't have a sub for that. But 5 times Y is going to be G, 5 times G plus 2. That equals 39. I've got to write this better because it looks like a 26. Let me write that better. 10 minus 2G. That works. I'm going to do that. I'm going to do lowercase g plus 4G plus 5 times 10. No, wait. That's G plus 2. I already used 10. G plus 2 equals 39. All right, there we go. Now we're set. All right, so 10 minus 2G plus 4G plus 5G plus 10 is equal to 39. 10 plus 10 is 20. I'm going to subtract 20 from both sides. So that cancels this one and this one. 2 plus 4 is 6 plus 5, that's 11. 11 times G is equal to 19. G is equal to 19 over 11, I guess. Let's try that one. Let me put it in for greens. All right, let's say 2, 19 over 11. I'm just testing the others. No, but there's 2 blues. All right then. If there's 2 blues, well, that was fun. How did I get so... If there were 2 more yellows than greens. So yellow equals green plus 2. Blues are 1 pound, greens are 4 pounds, yellows are 5 pounds. Total weight was 39 pounds. One times the number of blues would be 1 times 10 minus 2G. All right, let me make sure I did that part right. All right, b plus g plus g plus 2 is equal to 10. So I've got, no, I didn't do that right. I didn't subtract 2, did I? I didn't. Oh my goodness. I knew I did something wrong. So I have b plus 2g is equal to 8. So b is equal to 8 minus 2g. Hello. How did I not catch that? Abigail, why didn't you tell me I got that wrong? That's why it's not right. So sometimes I don't do things right. It's entirely possible. All right, so whenever you get a fraction like that, it's a little questionable because of the subject matter we're dealing with, right? Especially if it's nickels, quarters, and dimes, you can't have a fraction of one of those. It has to be whole coins. So that would be suspect. Same thing here would be suspect. There are other things where fractions are perfectly acceptable, but not when you're talking about quantities of things like this. So let me go back and redo that. So this is going to be 1 times b. That's going to be 8 minus 2g plus 4g plus 5 times g plus 2 equals 39. Okay, that should solve my problem. 8 minus 2g plus 4g plus 5g plus 10 is equal to 39. Okay, so I've got 8 and 10. That's going to be 18. So I'm going to subtract 18 from both sides. So this cancels. So I have negative 2g. I also wrote that down wrong. Negative 2g, so that's going to be 2 plus 5. That's going to be 7. So 7g is equal to 21. That's going to give me g is equal to 3. Okay, so now if I go in here, 3, take that one out. Now I really just need to find yellow, but I also need to prove that blue is what it is. So b is equal to 8 minus 2 times 3 is 6. So b is equal to 2. Okay, so I found that one. That's right. So now I can find what g is, or what yellow is, by putting in g here. So 3 plus 2 is 5. So yellows are 5. That should be right. Yes. Hallelujah. I got it right. Okay, so we're done with the lesson problems. Now we're back to the previous lesson that we did on Thursday with the rational numbers. I think that's like lesson 107. So we've got a number here, 1.213. It has 2 repeating digits. That is the number. We're going to multiply that by 100 because 100 has 2 zeros in it. So 100 times n is equal to 121 point. Is that right? 1, 2. Yeah, that's right. 3, and then 1, 3, 1, 3, repeats, right? Now we multiply that by negative 1n, and that's going to be a negative 1.21313 dot 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 repeating. These cancel each other out because when we subtract, they go away because they're perfectly lined up on top of each other. So now we just need to subtract these two. So 121.3 minus 1.2. 120. So 99n, because 100 minus 1 is 99, is equal to 121.3 minus 1.2, which is 120.1. We only have one decimal here. So when I do this, I'm going to multiply that by one place, one set of zeros, which is 10 over 10, So n is equal to 1201 over 990. That is your answer. Next problem, we have one of these where we have to find the point where they all intersect. So you're going to have an x, y, z problem where you're going to answer it like that, right? Only thing is we have missing values. So we need to create some substitution values that work. So here I see we have an x and an x. So if I multiply this one by a -1, that'll help. So a is x plus 2y equals 10. B is going to be x minus 3z is equal to -16. And C is y plus 2z is equal to 16. So I'm going to take A, x plus 2y is equal to 10. And I'm going to take B and multiply it by a -1. And that's going to be negative x plus 3z is equal to a positive 16. Because I just changed all the signs. That allows this to cancel. I get 2y plus 3z is equal to 26. That's going to be my D equation. Now, C has a y and a z. If I multiply this by -2y, then that gives me an ability to solve for z because I'll be canceling the y's. So I'm going to say -2 times c is going to give me a -2y minus 4z is equal to a -32. So this cancels. I have a -1z, and this is going to be -6. Multiply both sides by -1 or divide both sides by -1. Z is equal to 6. So in my solution, 6 goes here. Now I can solve for y by putting z in here. So y plus 2 times 6 equals 16. This is 12. Take 12 from both sides. Y is equal to 4. So 4 goes here. So now I can go up here where my A is, and it says x plus 2y. That's 4 is equal to 10. 2 times 4 is 8. Subtract 8 from both sides. X is equal to 2. So 246 is my solution. I'm going to go ahead and type it in just to double check. 2, 4, 6. That's correct. All right, 2 more problems, and then we're done. Okay, so here we have one of these that we have to conjugate to solve. But first we need to... Uh-oh, my pen's not working. There it is. What is up? Okay, it's working. Must have been something on my screen that was wonky. So 2i cubed minus square root of -3 times square root of -3 over 4 minus 3i squared. All right, so let's simplify first. So I've got 2 and I squared. If I do I squared and then I, that's the same thing as a -1, right? Come on, eraser. So 2 times -1 times I, and then if I take the negative out of here, I get I get square root of 3 times square root of 3, and then I get an I here and an I here, which we know is going to be, it's going to be -2i, and then I squared, negative square root of 3 times square root of 3 is 3, and then we have an I squared, which we know is a -1. So -2i minus 3 times a -1 gives me a positive 3. So what all of this does for me is it gives me 3 minus 2i in the numerator. All of this resolved to 3 minus 2i. That's my numerator. and I squared here. Now I'm going to do my denominator. I'm just going to move all of this over here. That's the numerator. I squared, that's 4 minus 3 times negative 1. So that's going to be 4 plus 3 equals 7. So 7. That's my solution. The only thing is, you can't have I in the same fraction. So we're going to rewrite it 3 over 7 minus 2I over 7. 3I over 7 minus, oh, that's not an I. Hello, take that off. 2I over 7. I think that's right. It's not right. What'd I do? Let me find out what I did. Okay, so the answer key just had 2 over 7 with I to the side, which is the same thing as 2I over 7. You can always take a variable and move it to the side. We do that all the time with X and Y. I can be done the same way. So I just added this as another potential or as another acceptable answer for the sake of, the way students type it in. It's right. It's just a format thing. So this is the right answer. It just needed to be added as an acceptable answer. Sometimes the book only gives you one of those, and sometimes it goes back and forth as to which one it gives you. So I try to catch all of those and put them all in. I don't always. So when I don't, I try to fix it. All right, so that one was right. Last problem. Yay. We're converting a rate to another rate. So we have 40 inches per 1 second to meters per hour. So first of all, we're going to go from inches to meters, and that's going to be 1 inch, 2.54 centimeters. 100 centimeters is 1 meter. So we'll do that first. So times 2.54 centimeters over 1 inch, cancels inches, times 1 meter over 100 centimeters, cancels centimeters. Now we're going to go from seconds to hours. We know that there are 60 seconds in 1 minute, and there are 60 minutes in 1 hour. So times 60 seconds in 1 minute, cancels seconds, times 60 minutes in 1 hour, cancels the minutes. So what we have is 40 times 2.54 times 1, and that's meters, over, actually, not done yet, 60 times 60 meters over 100 hours. Because we have meters as the unit of measure in the numerator, and hours is the unit of measure in the denominator. I'm not sure exactly how I wrote this. I do think it's like probably 40, 2.54, 60 squared over 100, and then it's probably meters per hour, or it could be meters per hour. I don't think it is though, because that looks like miles per hour. So I probably did meters per hour. We're going to find out. Let's put it in here and see which one is right. 40 times 2.54 times 60 squared. I know what's squared. And let's see what that is. 100 And let's see if I put meters up here. Meters, hour. Let's see if I did that. I'm going to copy and paste that. Copy. Okay. And that's correct. So I just left it in the fraction that it was in. So there you go. That's how you need to type it in. All in one fraction, not as a separate unit of measure. All right, so that's that. That is the last of lesson 111. And we threw those last few problems in there. Keep your skills fresh. All right, so that's all I have for this video. I will see you in beginning with lesson 112 in the next video.